Perfect. Let me go ahead and clear. Now let's go ahead and move on. So today what we're going to do is that we're going to go ahead and apply conditions. Again, they're statements that have to be true in order for us to automatically have the figure that we are given, okay? Now, our beautiful quadrilaterals are either going to be a rectangle, rhombus, or a square that's given, but we're going to go ahead and be very specific as to what we need to have in order for us to prove that we do have the figures that we need to have, okay? So the first one that we have here, or question for today, is how can we prove or how can we use the given conditions to prove that we have either a rectangle, rhombus, or a beautiful square? Now, here's our vocabulary. These are the definitions that define or automatically give us the figures that we have here. So rectangle, all we need is a quadrilateral with 4 right angles. A rhombus, a quadrilateral that has 4 congruent sides. A square is a quadrilateral with 4 congruent sides and 4 right angles. So we need another one? Another page? Okay, sorry. I thought we needed another one. So those are our definitions. Now, our conditions. The first one, guys, we have a condition for a rectangle. Now, in order for a quadrilateral to be a rectangle or have a condition is that we need to have a parallelogram, okay? If we're stated that we have a parallelogram and exactly one angle, or we're just given the measurement of one angle, happens to be 90 degrees or a right angle, then it's automatically a rectangle. So all we need to prove is that one angle in a parallelogram is 90 degrees. So 90 degrees. So one angle of a parallelogram has to be 90 degrees. If that is true, then we automatically have a beautiful rectangle. My second condition for a rectangle, if the diagonals of a parallelogram are congruent, then the parallelogram is automatically a rectangle. So what do I need to do? I need to prove that my diagonals, and we have a parallelogram, are congruent. If that is true, then we automatically have a beautiful rectangle. All right, what does that mean? So my first condition, I have my angles A, B, C, and D in my beautiful part. Yes, possible.
When you mean let's say that A, B, and B, C are congruent. Why do you mean?
So in this case, they all have to be congruent to each other. So this has to be congruent to this. This has to be congruent to this. They all have to be congruent to each other. So they're going to bisect each other, yes, but they're also going to be all same measures because whenever you add the measurements, they have to be the same measure and they all have to be bisected. So they all the same little pieces. So all we need to prove is that this length right here, A to C, is the same from B to D. As long as that is true, then we automatically have a rectangle. So let's say that you were asked to construct a pen for your pet or a little fence or a little kennel, and you want to do it so that it's rectangular. As long as you are finding the measurements from each of the diagonals or each of the opposite angles, and they happen to be the same distance, then you are very, very close to constructing that right angle. The right side of the rectangle. Now the next condition, and it has to be either or. So it's either this true or this is true. So one or the other. You don't have to necessarily have both true. So as long as you can prove one is true, then it's given for the rest. So my first one was to prove that I have a parallelogram. And if I do, and one of the angles happens to be 90 degrees, then we automatically have a rectangle. And, or my diagonals being congruent to each other. Okay. All right. Let's go ahead and go through examples. Let's go ahead and do number 1. Let's see if the given information is enough to necessarily state that the quadrilateral that's given is a beautiful rectangle. So it could be not. Is it enough? We probably need more. But let's go ahead and see. What do we have? We have EF. And we're told that EF is congruent to GF. So let me go ahead and highlight them. And if you guys have highlighters, go ahead and take them out if you have them. So we have EF and GF right here. Right? Two sides that are congruent to each other. But is it a square? It could be a rhombus. Two sides are already consecutive and congruent to each other. All right. Now, more information. What other item is given? What is this? FG and HE. So F. All right. Now, what do we see here?
Square.
A square so far. Okay. Now let me see. F, H, and GE. F, H. Right here. And then GE. What do you guys think?
A square.
It could be a square, but now we have, most importantly, the information that we need, which is the diagonals. Now, is that enough information to tell us that we have a beautiful rectangle? Yes, it is. As long as we have, or we can prove that it's a parallelogram, we have opposite sides are congruent. So we have these two sides are congruent. These two sides could be congruent, but we have also the diagonals congruent. So therefore, by side, we can go ahead and prove that, or the triangles that they construct, that rectangle. Check mark. Woo-woo. All right. Okay, let's go ahead and clear. Let's move on to the next one. Example number 2. Use the given information to determine whether the quadrilateral is necessarily a rectangle. Explain your reasoning. This time we're given the measurement of FEG equaling 45 degrees and GEH equaling 50 degrees. All right. Now, from F to E to G, what angle is that one? Right here. And that one measures what? 45. So let's go ahead and label it as 45. The other angle that we're given is angle GEH. So this is this angle right here. This one measures 50. All right, so I want you guys to think about this one. What do you guys think? Is it enough information to give us or to tell us that it's a rectangle or not? Think to yourselves. Go ahead and tell your neighbors. What do you guys think first? Tell your neighbors. Discuss with your neighbors. You have beautiful neighbors. All right. I'm going to randomly select somebody. So be ready, guys. Hold on. Hold on. Okay, let me go ahead and select somebody because I heard interesting conversations going on. Dios mío. A ver. All right, Nelson. What do you and your partner discuss? What? So we have one angle that measures 45, the other one 50. What do you think? Are we going to have a rectangle or not? Why not? it doesn't equal to 90. We have to have one angle, at least one angle, one angle that is 90 degrees. One angle. Okay, now here in this case, we have these two angles. Whenever we add them up, what is their sum? 45 plus 50. 95. Does 95 equal 90 degrees? No, so therefore not a rectangle. Okay, so we applied our beautiful conditions. Let me go ahead and clear. Sorry, guys. Everybody had that? I'm going too fast. Sorry. So I want enough time to have for the activity. It takes a lot of time. Okay, go ahead and go. All right, ready? Let's see. Clear. Perfect. Okay, let's go on to now our beautiful. I'm going to go ahead and skip this one, guys. I'm going to go ahead and go on to our next condition. Sorry about that. I apologize. The next condition is on a rhombus. Now it states that all we have to have is one pair of consecutive sides, and all they have to be are congruent. If that is true, then the parallelogram is automatically a rhombus. Second condition is the diagonals of a parallelogram, are perpendicular, then the parallelogram is automatically a rhombus. And the last one, our beautiful diagonals have to be bisecting our pair of opposite angles or a pair of opposite angles. Then the parallelogram is automatically a beautiful rhombus. So those three conditions have to be true. Either way, it has to be an or. So basically, either the first one's true, the next one's true, or the next one's true. As long as we have one to prove that is true, then we automatically have a beautiful rhombus. Now, the first one states that my sides that are consecutive. Consecutive means that they're right next to each other. What does that mean? So for example, if I pick EAF, this side. A side consecutive, it's the one next over. So which one's next? Either EH or FG. The same goes with the other side. So if I had GH, either FG or EH have to be consecutive and congruent. As long as that is true in a parallelogram, then we have a beautiful rhombus. Now, my diagonals have to be perpendicular. That means that whenever they intersect, like this and like this. So go ahead and draw that in, guys. They have to equal 90 degrees. Okay, they have to be perpendicular to each other. My beautiful diagonal FH or HF and EG or GE. And the last part are my beautiful opposite pair of angles. So for example, I have this angle right here. As long as I can prove that the four parts or the four angles are congruent to each other, that means that my diagonal bisects and I have a beautiful rhombus given as my parallelogram. Okay. All right, ready to put this into play? All right. So everybody has this? Yes. Okay, everything's already printed out for you guys. Nice and beautifully done. Okay, example number 3, guys. What is the value that makes X, the parallelogram, a rhombus? What value of X makes the parallelogram a rhombus? Now, what do we need to prove? What are one of my conditions, guys? Consecutive sides have to be congruent. So let's go ahead and see. These two beautiful sides have to be congruent. So therefore, let's go ahead and see what the value of X has to be. So 14 minus X equals 2X plus beautiful 5. Consecutive. Sides must be congruent. So let's go ahead and solve. What would be my first step? Add X. So let's go ahead and add that beautiful X. So we have 14 equals 3x plus 5. Subtract our beautiful constant. We're left with 9 equals 3x. Last step. Divide by beautiful 3, and we're left with x equals positive 3. So we need to give the statement x must equal 3. So that is the statement that we need to give. X has to be 3 in order for this figure to be a beautiful rhombus. Otherwise, if it's not 3, then it's not a rhombus. Okay. Ready for the next one, guys. Yay! And we're on to beautiful squares. All right, and the last part, condition. Condition for squares only has one. It says if a quadrilateral is a square, then it's automatically a rectangle, a rhombus, and a parallelogram. So everything that applies to parallelograms, everything that applies to rhombuses, everything that applies to rectangles is true for a beautiful square. So my diagonals have to be congruent to each other. Whenever they intersect, they have to be perpendicular to each other. Consecutive sides have to be congruent to each other. One angle has to be 90 degrees. Then we automatically have all those beautiful statements true. Okay. All right. So our last example, guys, for today. Everybody has this? Yes. Awesome. So let's go ahead and do this one. What value of x makes the parallelogram a beautiful square? So what has to be true for this beautiful expression? So what is it pointing at? The middle part, right? This little angle right here. Now, what do we need to know about these angles? They have to be what? Specific measurement. It has to be 90 degrees. So this has to be 90 degrees. So let's go ahead and see what the value of x has to be in order for it to be 90 degrees. So we have 13x plus 5.5 equals 90. Subtract 5.5. And we're left with 13x equals 84.5. And the last step to divide by 13. So we're left with x equals. You guys have calculators. 8.5 divided by 13. 6.5. So again, x must be or equal 6.5 in order for this beautiful parallelogram to be a square. Again. All right. Any questions on this? Yeah. Okay. Well, what questions do you guys have? Oh, sorry. Let me go back. What questions do you guys have?